Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial. Suppose you want to start your own business in 10 years. You plan to save funds to invest in business. You have determined that you can save 5,000 per year for 10 years at 7% interest. If the first 5,000 deposit isn't made until 1 year from today, how much money will you have in 10 years when you start your business? So, here has several things you have to remember, that you want to start your own business in 10 years. That means after 10 years you are going to start your own business. You plan to save funds to invest in business today. You have a plan today to save funds. You determine that you can save 5,000 per year. 5,000 per year. So this talks about that it is an annuity. It is an annuity because you save 5,000 per year for 10 years at interest rate is 7%. So 10 years is the value of N, 7% is the value of R, and this 5,000 is your PMT, and question is arise, how much fund will you have at the end of 10 years? But here is said another word, you have to remember that if the first 5,000 deposit isn't made until 1 year from today, until 1 year from today, it says that it is the ordinary annuity. It is the ordinary annuity. It is the ordinary annuity. So you can solve the problem. So we have learned to solving this annuity problem, that is the formula format. Formula. So we have given formula. You can put down future value of annuity formula, future value of annuity formula. Then you can solve your problem. Again, we have learned timeline method. Timeline method. So you can also use timeline method. So you can draw your timeline 0 to 10, and it will start 1 year from today, that is 5,000. So in this way you can solve your problem. You can solve your problem, that is 5,000. So yes, here you can put down 5,000 and draw your timeline in this way, then solve your problem. And here you can put down your formula, then you can get the result as well. But today we will try to solve this problem by the use of tabular format, table use, by the use of table. So, then we can write down the formula for tabular format. Future value of annuity equal to PMT into future value interest factor annuity, interest factor annuity R and N. That is our formula. FVA, future value annuity, PMT payment, FVIFA, future value interest factor annuity R, rate of interest, N, number of period. So, that is our formula by the use of table. By the use of table, FVA equal to PMT into FVIFA R N. That is our desired formula for finding future value of annuity. So, from our problem we know that is the future value problem and ordinary future value problem, future value of annuity problem. Then we can write down our formula. If we put down the value 5000, FVIFA, rate of interest 7% and number of period 10 years. Number of year equal to 10. Number of year equal to 10 or 10 years. So, now we have to download financial table. Financial table, you can download any kind of website. If you write down on the Google financial table, then you can download it from your computer or mobile phone. So, it is very much available all over the world. Only search financial table. If you write down financial table for fin table, then Google will show you several tables. So, you can download any one of these. So, from your financial table, you can see. You have to at first go the name of the table, future value interest factor annuity, future value interest factor annuity, future value interest factor annuity, FVIFA. Then what will happen? Then you have to R, value of R is 7%. So, you have to find out the value interest rate 7% and number of period 10. Whenever intersect these two things, this is our R 7% and this is our N, and where these are intersect, that is our desired value. You can see 13.816, 13.816, that is our desired value, 13.816. So, if we find in this way, then it is clear for us. R equal to 7%, N equal to 10 year. So, that is the 10 year and 7% where intersect, that is our desired value 13.816, 13.816. So, if we put down this value to our calculator, 13.816, 69,080 taka. So, how much money we will have in 10 years when you start your business? If first payment start at the end of year 1, that is ordinary annuity, then our amount should be 69,080 taka after 10 years at the rate of interest is 7%. Now, here is another portion. How much would you have if you deposit the first 5,000 today? If you deposit today, then what will your amount? If you deposit today, that means it should be annuity due. Here said today, you deposit 5,000 today, that means a start of your period, today you deposit 5,000, that is your last deposit, start of 10 years. So, it is the problem of annuity due, future value of annuity due. So, you can write down the formula: future value annuity due equal to PMT into FVA R N 1 plus R into 1 plus R. So, that is the formula for future value of annuity due by the tabular method. So, we can write down our payment is 5,000, FVIF 7%, 10 year 1 plus 0.07. So, if we solve this problem, then we can have our desired result. FVIF 7%, 10%. So, we are seeing in here 13.816, 13.816, 13.816, 1.07. Then what will happen? Our result 5,000, 13.816, 1.07 into 73,915.6. So our desired result is 73,915.6. So their result may be some point little bit different if you use the tabular method. So no problem. So if your procedure is correct, then the result should be correct or near about your result. So 73,915.6. So if your first payment start today, then at the end of 10 years, your fund will grow 73,915.6 taka. Now this problem we can also solve by the use of our required formula that we have given. Then PMT into 1 plus R power n minus 1 divided by R. So if we put the values we have, then here you have written down given the information, and put down this information in here. Then our result would be 1.07 power 10 minus 1 divided by 0.07 into 5,000, 69,082.23. So that is the near about our result, previous result. So our result 69.082.23, that is our answer. So the rest portion, how much would you have if you deposit first 5,000 today? That means if it is annuity due, future value of annuity due, then what will happen? So this is your actual formula, and this will be multiplied by, this formula will be multiplied by 1 plus r. So, this will be our result, this will be multiplied by 1 plus r multiplied by 1 plus r, and it should be 69,082.23 into 1.07. Result should be 73,917.996, where you can write down 73,918. So, that should be exact answer of our materials. So, if we use the financial table, then there may be little bit different to this result, but not so much different. It should be different slightly 2 taka, 3 taka, or more maximum 5 taka may be difference, because we ignore in a table for the decimal after the point, several decimal point we are skipping in a tabular method. That's why result may be a little bit different, not too much different, but little bit different. Now, suppose you are considering an investment that pays 5,000 per year for 10 years, and your opportunity cost is 7% interest. If you don't receive the first 5,000 payment until 1 year from today, what is the most you should be willing to pay for the investment, and how much would you be willing to pay if you receive the first 5,000 payment today? So, this problem says that suppose you are considering an investment, that means if you make an investment today, then you will receive 5,000 taka per year for 10 years. So, if you invest today with such a project that will give you 5,000 taka each year for 10 years, your opportunity cost is 7%. That means you have to purchase that investment today. Then here has said that how much would you will to pay to receive this investment today. That means it is the present value of annuity. It is present value of annuity, because per year for 10 years you are receiving 5,000 taka. That is the present value of annuity. And here I said in word, if you don't receive the first payment until 1 year from today. So, until 1 year from today, this is our timeline starting from 0, 1. So, whenever this one period is end, 0 to 1, end the one period, your first payment start from here. Your first payment start from here. That means the first portion is ordinary annuity, and second portion, how much would you willing to pay if you receive the first payment start from today. That means your first payment whenever, then second portion first payment will start from at time 0. So, that is annuity due. Now, we can solve this problem by the use of timeline, by the use of formula, or by the use of table, financial table. Any one of these you can use to solve this problem. So, I am opening my virtual whiteboard. So, here is the formula for ordinary present value of annuity. PVA equal to PMT into 1 minus 1 by 1 plus R power n divided by R. You know it very well, the formula. You have given the formula, your materials, the essentials of managerial finance, the Verslev Brigham. So, that has given very nice materials. So, we can try to solve this problem. 5,000 into 1 minus 1 by 1 plus 0.07 power 10 divided by 0.07. So, then if we use our calculator, then the result should be clear for us. At first, 1 divided by 1.07 power 10. .07 power 10. 1 this answer, 1 minus this answer, then the answer divided by 0.07 into 5,000. So, result should be 35,117.9077 in my calculator shows these result. So, you can write down about to 35,118 taka. So, here has said if you invest today or you purchase by this 35,118 taka today, if you invest today, then from the next year this investment will provide you 5,000 taka for the next 10 years. This will give you next 10 years as 5,000 taka. So, that is obviously a good investment. Here the last portion has said that how much would you willing to pay if you receive 5,000 taka payment today. That means here is your first payment. What will happen? So, That is very easy for us. Whenever annuity due, formula will be the same, only multiplied by 1 plus r, multiplied by 1 plus r. Whenever annuity due, then only multiplied by 1 plus r. So, then we if you use this formula again, and we will multiply this 1 plus r, we will multiply this 1 plus r, or 1.07, then the second portion will be result in here. So, into 1.07, this will result 37,576.16 taka. So, if your first payment start at time 0, that means start today, then you have to investment more amount, and we know that annuity due is always time more amount. That should be, you have to invest 37,576.16 taka. You have to invest to, if you try to receive this benefit, then you have to investment today. So, this is the solution of present value of annuity and annuity due, and we have also discussing the present value of ordinary annuity and annuity due, and future value of ordinary annuity and annuity due. So, we will see this problem by a tabular method. PVA equal to PMT into PVIFA. That is the name of our table, R and N. So, that is the formula for our tabular method. You can download financial table, any kind of financial table from the internet or online, that is very available table, then you can download any one of these. So, if we put our value 5,000, PVIFA, our interest is 7%, and number of period is 10. Clear? And now, if we try to find out the value from our table, the name of our table is present value interest factor. R, rate of interest should be 7%, and number of period is 10. Whenever these two are intersect a point, that should be our desired value. So, now we see the table. First table, future value interest factor. No, we need not this table. We need not this table. We need not this table. Then we are seeing future value annuity factor. Also, we need not this table. Then present value interest factor. So, also that is not matching to desired table. And here present value annuity factor, PVIFA, the name of our table PVIFA. So here I said 7% rate of interest, and the period is 10. So please carefully see the value. N, that means number of period is 10. R, rate of interest is 7. So if intersect this value, that would be our required value. So I think this should be our required value, 7.023. So that should be our intersect point. That should be our intersect point. Intersect point. 7 point. Can you see? Can you see? That should be our intersect point. 7.0236. So if we put down this value to our formula, then we can get the result. Result may be little bit different, but result is correct. 7.0236. 7.0236. 7.0236. Then if you find 5,000 into 7.0236, again our result should be 35,118. 35,118. That is our answer. 35,118. That is our answer. So for the next portion, for the annuity due, we know that in here only multiplied by 1 plus r. We know that 1 plus r for the annuity due whenever it is due. So that is very easy for us. So in the same way, we have to calculate all the things and multiply with this 1.07 into 1.07. So in the exam, you have to, these portions should be, you have to do new. Remember that whenever you provide, you will do in exam, then for the calculations of due, you have to write down newly things. All things should be new. I am doing it for my purpose to make you know how to calculate. But whenever you do this in the exam, then you have to put all the information new for the calculation of due, present value of annuity due or future value of annuity due. Then you have to write down the formula newly. Okay? Can you make you understand? And this should be answer. Our should be answer should be our answer 37,576.5 526 and 37,576. That is our answer. Now we will see what is the present value of a 3,500 annuity that will be paid forever beginning in 1 year if the interest rate is 7%. That will be paid forever. Perpetuity. What is the present value of 3,500 annuity that will be paid forever beginning in 1 year? So it is called perpetuity, present value of perpetuity. So PVP, present value of perpetuity, equal to PMT divided by R. So here our 3,500 divided by 7%, 0.07. So what will be our result? Result should be 3,500 divided by 0.07, 50,000 taka, 50,000 taka, 50,000 taka. So our result should be 50,000 taka. And again here has said that what is the value of this perpetuity if the interest rate is increased to 10%. So simply where 3,500 divided by 0.10. So 3,500 divided by 0.10, that is 35,000. So present value of this perpetuity is 50,000 when our rate of interest is 7%, and if the interest rate is changed to 10%, then the present value of perpetuity should be 35,000 taka. That is our answer. Now we will see, consider the following uneven cash flow stream: 1,000 at the end of year 1, 5,000 end of year 2, 8,000 end of year 3, 2,000 at the end of year 4. If your opportunity cost is 10%, what is the most you should pay for an investment with this payout? So here has a very much understanding that what should most you pay for this investment. So there has an investment opportunity. If you purchase this, this will provide you 1,000, 5,000, 8,000 and 2,000 at the end of year 4. Opportunity cost 10%. So how much amount will you should pay? So that should be the present value of this amount. If you are to invest is cash flow when you receive it, how much would your investment be worth at the end of 4th year? And here is said, if you were to invest is cash flow when you receive it, whenever you receive it, and then you will invest it again, and what will happen after at the end of 4 years? So that is the future value. So in this problem we have two types of problem. So one is present value problem, another is future value problem. So, this is our virtual whiteboard. So, at first we have to draw our timeline 0, 1, 2, 3, 4. So, here I said at the end of year 1 you will get 1000, at the end of year 2 you will get 5000, at the end of year 3 you will get 800, and at the end of year 4 you will get 2000. So, this is our problem. So, here I said you will receive 1000, 5000, 800 and 2000. If you wish to get such type of amount, then you have to invest today. What will you invest today? That is our problem. So, you have to find out the value of n. You have to find out the value of n. 1000, that should carry n equal to 1. 5000, n equal to 2. 800, n equal to 3, and 2000, n equal to 4. N equal to 4. So, that is very simple. We know our formula, present value formula. Present value equal to future value divided by 1 plus r power n. So, that is our single amount formula. So, here is a several single amount 1000, 5000, 800 and 2000. So, if you add with our problem one after another, then we will get our solutions. FV divided by 1 plus r power n. So, in this way it shall be continue whatever we need. So, first we have 1000 divided by 1 plus our rate of interest is, opportunity cost is 10%. Can you remember? Our opportunity cost is 10%, r equal to 10%. We know it very well. Power 1, then 5000 1 plus 0.10 power 2 plus 800 1 plus 0.1 power 3 plus 2000 divided by 1 plus 0.1 power 4. Then what will be our result? If we calculate this amount by our calculator, then we will find 1000 divided by 1.1 power 1. $909.09 plus 5000 divided by 1.1 power 2, 4132.23 plus 800 divided by 1.1 power 3 then result 601.05 and last one 2000 divided by 1.1 power 4, 1366.02. Then if we add with this, then we will have our required present value 909.09 plus 4132.23 plus 601.05 plus 1366.02 7008.39. So if you wish to receive this opportunity, that means if you want to get after 1 year 1000, second year 5000, 2 year, third year 800, fourth year 2000, then you have to invest today 7008.39 taka to receive that opportunity. And again here has said that if you receive each year that amount, then you will invest it again in a bank. Here I said if you were to invest is cash flow when you receive it, how much would your investment be worth at the end of year 4? That means this is the future value. Whenever you receive this amount, as like whenever you receive this amount 0, 1, 2, 3 and 4, here I said you are receiving 1000, 5000, 800 and 2000, and you will invest it again, and what will happen at the end of year 4? At the end of year 4. So what will be our value of n? N should be 1, 2, 3. First 1000 carry the compounding n equal to 3, then equal to 2. 5000 carry the compounding year 2, 800 compounding year 1, and 2000 n equal to 0, because at the end of year 4 what will your amount? So now you will simply use the formula for future value formula. That is very easy for you using the formula. So that is our future value formula. Future value equal to present value into 1 plus r power n. So then it is the whenever whatever you like. So here is the several single amount. So whatever the amount, no problem, you add with this amount, This is a formula in here. That is PV1 plus R power n, and continue whatever like. First one, 1000 carry the compounding 1 plus 0.10 power 3. Then 5000 carry the compounding period 1 plus 0.1 power 2 plus 800 1 plus 0.1 1 and 2000 1 plus 0.1 0. Then by the pressing in your calculator, then result should be, then I will press my computer calculator 1 plus 10 power 3 plus 5000 into 1.1 power 2 plus 800 1.1 power 1 plus 2000 1.1 power 0. That should be 10,261 10,261. So if you receive this amount and invest it again, then at the end of year 4 your amount should be 10,261. So that is a good business. You are purchasing this investment at 7,008 taka, and from your this investment you will receive at the end of year 4 10,261. So that is a very good examples that is carry present value and future value at a time. So all of these problems can be solved by tabular method. That means you can use the table. So simply whenever you calculate future value of a single amount, then you can use the table as a like financial table PV, FVIF, RN. So you can use the table. The name of the table is future value interest factor. Then here is the should be put out the present value, which would be convert to the future value. This is your table. R rate of interest and N number of period. In the same way you can solve for present value problem. Present value equal to future value present value interest factor R N. So the name of our table is present value interest factor. So here should be your future value, and you should use by this table by the sections of interest and N. There you get a desert value. If you multiply this value, then you can get your desired amount. So that is also easy for you, as before we have learned these types of techniques. So as the same way, whenever the mixed stream problem, year values PVIF interest factors, then values, multiplied values. So here 1, 2, 3, 4 values as like 1000, 5000, 800, etc. Then you can take the present value interest factor table, as here there has the 7% interest. So if you find the table present value interest factor table with the rate of interest is 7%, then here you will get several values. Then if you multiply these values, then here has the different values, and at last you have to add all of these values to find out total present value. So in this way you can solve the mixed stream problem. So at last we have seen that we can solve the problem, all types of problems we have. We can use formula method. We can use timeline method. Then we can use financial table method. Another method we have financial calculator method, but that procedure is not shown in here because of my lackings. I have not financial calculator, so that's why this procedure actually is not shown here. And others, all kinds of problems of finance related time value of money, that's we are trying to solving here. This all about today. Stay home, stay safe, try to maintain a safe social distance, try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.